file transfer and electronic mail, two protocols, FTP and email. And so we'll talk about SMTP, which is the mail transfer protocol, and FTP. And we'll show you how they are different. And then we'll talk about POP3 and IMAP. So FTP is used for file transfer. Some of you might use browser for FTP, and you can just write in the browser FTP : whatever. But some of you might have an FTP client just for file transfer, FTP client. Some of you might just do FTP in a task box where you can say FTP program, and then you have to write down get, put everything yourself. But FTP is a very old protocol, one of the original protocols on the internet, and it is in binary. So you cannot read the messages just like that, bit by bit. Those are bits. But anyway, there are two kinds of, actually FTP sets of two connections. First thing to notice is that it uses port 21. That is what we call the well-known port. But you can, again, just like HTTP, you could design your server so that it uses any port that you want, and then the clients have to ask for that port. And so if client doesn't say any port, then FTP uses port 21. But it uses two connections, not one. HTTP used one connection. This one uses two connections, one for control and one for data. What is data? What is control? Data is the thing that you want to transfer. Control is everything else that the computers have to exchange in order to get you the data. All the overhead messages are control. Okay? All the connection setup messages are control. So it has a separate connection for that, and then separate connection for data. And that means control is out of band. Means control does not use the same connection as data, it is out of band. In band is the opposite of this. In band means data and control use the same connection. For example, HTTP was in band. All right. Control connection is persistent. Data connections are non-persistent. So here, once you connect to an FTP server, it asks you for username, password, and connection is set up until you say quit, bye, or something like that. The connection is there. What connection is there? Control connection is there. Right? Data connection, you say get this file, it will give you the file, it set up a connection, get the file, close connection. So the data connections are non-persistent and stateful, and the server has a complete state. It knows what directory you are in, what device you are in, and so on and so forth, what is your username. So until you close the connection, the control connection, the whole state is maintained. This is in some sense opposite of HTTP. Okay? And the commands for FTP are, as usual, user, username, password, list. List is simply a command which lists the files directory. Then we have retrieve, file name, store, file name, status, and then the status numbers are very similar. 331 username. Okay, so they may not be similar to HTTP. So, but so for example here, 331 username. Okay, password required. 125 data connection ready. So there is a number and there is a text. The text is what is presented to you. The number is what these clients and server understand. If you do FTP in a command box, in a DOS box, and then you can say help, it will list a whole set of commands. Anyway, the key thing to remember in FTP is that there are two different TCP connections, a control connection and a data connection. As opposed to in HTTP, there was only one connection that was used for both control and data. So the main difference in FTP is that it is two separate connections. All right. Then So every time you retrieve a file, a new connection is set up and broken down, and the file is sent. File is done, and the control connection remains throughout. So the final thing we come to is, not the final thing, but the next application we come to is electronic mail. So most of you have been using electronic mail, and at least know that you have a mail server. Your mails come to the server, and your computer is what we call a mail agent or user agent. And some of the mail can come to the user agent, and most of it is stored in the server. And once it is transferred, you can delete it from the server. Anyway, servers use a protocol to talk to each other, and that protocol is called SMTP. Simple Mail Transfer Protocol. So when you want to send a message to somebody else, you just give it to the server, and it doesn't really gone anywhere other than the server. Server keeps a queue of messages to send, and it is quite possible that the server of the receiver is not available right now, or something like that. Then it will keep trying. All right. So basically, each server has a queue of messages that need to be sent out to the next server. Now, it doesn't have to be directly to the destination. It is quite possible that a message can go to some intermediate server. From there, it can go to some other server before it reaches the final server. So it is a store and forward kind of thing, as opposed to FTP, where there is no store and forward. In FTP, the destination and the receiver have to be both up at the same time before FTP can take place. You cannot submit a command today and get the answer tomorrow in FTP. In mail, you can do that. You can send the mail today and get it tomorrow. So basically, SMTP is the protocol. SMTP stands for Simple Mail Transfer Protocol. This is one of the oldest protocol. Basically, when they invented internet, one of the very first applications that they started using was the mail. And it allows only 7-bit ASCII messages. In those days, back in 70s, we didn't have all these different encodings of the characters that we have today. And only thing we knew was ASCII. In ASCII, every character is encoded as 7-bit. Every character is from 0 to 128 because of that 7-bit. And so that's the only thing. Now, if you want to send a program or something which is a binary object which has 8 bits, you need to convert 8 bits to 7 bits. So there are methods of changing, coding 8 bits to 7 bits. And basically that means you need more than 1 byte to send those extra bits. And this protocol originally used port 25. So that is port 25 is the default port. So far we have 3 applications. What is the default port for HTTP? Port for HTTP? 80. For FTP? 21. And for SMTP it is 25. It is not necessarily the only port that you can use. You can use any port you want, but the users have to know that port then, and then they can use that port. Otherwise they will be talking to the wrong port. So here's the exchange. And again, interesting thing is that you can do this on your computer. You don't need a mail program to do this. On a computer, you can say telnet to mail.cs.wuchtel.edu port 25. Telnet means basically you are connecting to that port, and everything that you are typing is going to that port. Okay, so that port doesn't know that it is talking to you directly on your keyboard and not to a program like Outlook. Outlook does this for you. Then server will say, when you say this, the first thing server will say is 220 postoffice.cs.wuchtel.edu Microsoft ESMTP mail service version so and so forth 75 ready on Tuesday 13th September 2011 this time. Okay, then you can say hello, and hello has to be spelled like this, HELO. acm.org. Now why HELO and not HELLO? Because every bit and byte was important in those days in 74 when it was done. And why spell two letters when only one will do? Right? So they said hello acm.org. So this one says 250, server says 250, post office sees. Anyway, one of the things you will notice is that every time there is a number, just like we sign HTTP, that number is the status code that the computers can understand. And then there is a text which computers don't care. They just flash it to the user. The users can understand those things. So this one says 250, post office sees blah 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 address. Then you can type mail from jane@acm.org. So this is the mail from field. Then it says sender OK. Then receipt to, this is the to field, and then it says OK. Then you say data, and then you can start typing whatever you want to type. It will say, first you will say start mail input, end with crlf.crlf. You know what is CRLF? Yeah. Character and line feed. So that is character 13, LF is 10. SE character 13 and 10 followed by a dot. And so I typed, actually this is all I typed. So I typed this is test email dot. This serves as an example for CS473 class dot. And then on the last line I said dot. Right? When the last line is dot, that means this is the end of the message. That dot will not be sent, but basically this is the end of the message. And so 250 mail queued for delivery. And then I said quit and said bye. And you can do that yourself on your computer. Yeah. Okay, so basically I told him who I am. So I said that I am calling from acm.org. This is my site. It could be harvard.edu or something. Okay, then it says this server says okay, this is coming from this website, not this site, cs.boostal.edu post office. So that's its name, and that is the IP address. That is the IP address for this same thing. I'm sorry, does that answer your question? Yeah. Okay, what is the question next? Yeah.
Is there any sort of security built in so that I can't just say I'm like president at whitehouse.gov?
Yeah, there is no security built in even today. You can go to Outlook, and when it says username, just put the president at whitehouse.gov. It will take it. And when you send the email, it will go. And when the person receives it, it will say president at whitehouse.gov. However, if they wanted to trace it back, they can trace it back to you because of the IP address.
So if you send it from some random internet cafe.
I have gotten emails from god@heavens.com, right? Obviously from president at whitehouse.gov, everybody has gotten. So you can write whatever you want. They don't check that.
So when you say hello acm.org, what's the point of that if it doesn't really even check anything?
Yeah, it doesn't check anything. It doesn't check. But basically, when they designed the protocol, they just designed it so that first you tell where are you calling from and where you want, and then you say what is your email address. And so first it said acm.org. Actually, that is kind of irrelevant because when I say mail from jan@acm.org, I'm telling the same information again. Right? So the first handshake actually doesn't do much. Now this is a really good exercise. You can just try it from your DOS box. Everybody understands what is a DOS box, right? And so you can just try it, and I typed it as again before. When you type something, it will not be echoed. And that's the problem. Whatever this response comes back will be written up. So you will get the server responses, but when you type hello, HELOACM.org, that will be blank. You just type HELOACM.org. Also, another thing you can do is if you have a program like Wireshark, which we actually provide to our students in network security class. Wireshark lets you trace all the, basically see all the messages that are going out of your computer. If you had Wireshark, you can see these messages going in and out of your computer exactly as they are written here. And so even if you use Outlook, Outlook does send these messages to the server. Outlook tells the server, hello, this is acm.org, and then it says mail from, and so on and so forth. So Outlook is simply a what they call interface. It uses this protocol to talk to the server. Now I just put here, I could have sent the mail to White House or whatever it is, so that doesn't matter.
It's saying, I'm trying to say unable to relay for any other email.
Unable to relay. It says unable to relay? Yeah. Okay, so that is the built-in feature at WashU server. So WashU server does not let unauthenticated users. If you are authenticated, then yes, you can send it. If you are unauthenticated, then only you can send. Actually, I don't know what you can do, because unauthenticated, it will probably let you send to only Goostal people or something like that. But you have to give the username and password. But this is the starting, simplest, unencrypted mail. In fact, today's email, if you were to send it today, this one worked actually from my home, or maybe office. I don't remember whether I did this in the office or home. But at the office, there is no authentication required. But from home, if I do it, I get that relay message issue. If you are connected on the wireless, there are two wireless connections. One is secure and one is normal one. If you are on the normal guest one, obviously they have to have protection. But so otherwise, I will have to put a command here, user and password, to authenticate myself. All right. So that gives us a summary of the difference between HTTP and SMTP. HTTP can be persistent or non-persistent TCP connection. Everybody remembers what is a persistent TCP connection? Right? You did probably in the homework as well. But persistent means you don't close you can close the, non-persistent means you close the connection after every object. Here in SMTP, this whole conversation that we had was one connection. This is mostly pull, means you get the information from the server. This is mostly push. SMTP protocol is used to send the mail, not to receive the mail. Okay? So this is mostly push. Accepts, I'm going to come to the receiving mail in a minute, if that is your question. But accepts binary objects. HTTP was designed when we understood the binary objects. This accepts only 7-bit ASCII. This has one object per response. You can get multiple objects per message. Okay, so you could have a message which has a picture in it and web pages and everything else. All right, so how do you get the email? So to get the email, you need another protocol, which is the access protocol, to get the email from your server. And the protocol that is used for access is called Post Office Protocol, POP. All of you have heard POP, right? But never knew that was Post Office Protocol, right? So POP is the Post Office Protocol, and nowadays we have version 3 of that, so we call it POP 3. Yeah, right. So you are looking from the client's point of view.
Yeah.
From the client's point of view, this is a push and this is a pull. And when you go to Exchange, when you send a message, you are pushing. When you are receiving a message, you are pulling. Is it any different? The summary is that for sending SMTP, for receiving, you need a POP protocol. And therefore, sometimes you have two servers. And you have to write down smtp.yahoo.com, pop.yahoo.com, right, for sending and receiving. Sometimes there is only one. So in our case, we write down mail.siege.bustal.edu because the same server does both, right? But it uses two different protocols, right? So even though it is mail.siege.bustal.edu, same computer, but when I send the email, I talk to it by SMTP. When I receive the email, I talk POP. So first of all, when you are talking to the server, you have an IP address. Doesn't matter what was your IP address yesterday, who cares? But right now when you are talking to me, you have an IP address and I have an IP address, so you just use the SMTP protocol. Now, as I said, it is mostly push. That means mostly the client will send the message to the server and say, look, I want to send this message. Until then, it will be, if the server is not available, your message might be queued in your own computer. So there is a queue in your computer too, right? Outlook has a queue, right? When the server is available, then it is pushed to the server. At that time, you have whatever queue IP address you have, that's it. Basically, that address is used. But generally, the mail is kept at the server until the client says that I want it. So for example, I don't have BlackBerry, but I have iPhone right here. If the email is there, but it doesn't come to me, until I go to the email program. When I go to the email program, it starts pulling everything from the server and says you have 5 emails. Right? If I don't go to that program, I could program it. Actually, it's just the program itself which decides not to do that. But I could have another program that could just pull it every minute and tell me that now you have 15 messages. But so that's all detail of the program, nothing to do with the protocol. The key part of the protocol is these messages that we talked about, and those are fixed. How the interface does it is there's a lot of leeway there. There's a lot of ways different interfaces provide different facilities to the user. All right. So the key point I wanted to say was that SMTP and POP are two different messages, the different protocol. SMTP is send, POP is for receive. Another receive is IMAP. Another receive is HTTP. Lot of people today are receiving email by web page. So when you have a web email, such as Yahoo, Google, everything else, you may not be using the SMTP and POP protocols. Those could be simple get and put messages, HTTP messages. So now POP3, in POP3, here's a sample POP3 sequence. POP3 server ready, you say user Bob, server says okay, plus okay. Pass hungry, this is the password. And then it says okay, user logged in. Then it says list, client says list. Then it says, well, you have 2 messages waiting. First one is 498 bytes, second one has 912 bytes, and then they dot. Right, that means at the end of the list. Then it says retrieve 1. And so it sends you 1, and then sends a dot. Then you say delete 1. You don't have to say delete 1, but if you want to delete it, you say delete 1. Then you say retrieve 2, and delete 2, quit, and now. Next time when you come back, 1 and 2 are not there, because they have been deleted. If you don't delete 1 and 2, when you come back, it will say I have 2 messages for you, again same messages. Yeah, but I think it will renumber it if you just get out of there right now. If you quit and then you come back, it will say I have message 1 and that is 912 bytes. But right now, just for the sake of simplicity, because there will be 2,000 messages, if you read 530th message and then now you have to renumber the rest of them. So for this session, I think the numbers are fixed. All right, IMAP is Internet Mail Access Protocol. It is more sophisticated than POP3, and messages can be moved from one folder to another, and the users can only get the headers or the component of the messages, and there is the IMAP organization. Again, because we are not going into detail of IMAP protocol, in the POP3, there was no push as such. Basically, you have to say retrieve 1 to get the message, list to get the list. So you have to ask for it and you get it. Maybe in IMAP there is a command which says, oh, here is your list, even if you didn't ask. But I would be surprised though, because most clients like this, they are not ready for just a whole bunch of information unless they ask for it. So generally the servers don't take the lead. You have to differentiate between what is happening in the background and what you see in front of you. So it might say push email means it gives me a message saying that, okay, you got 46 email, but that doesn't mean that the server pushed it into it. It is pushing to you. Server would have gone to server and say, please tell me how many emails you have. So it is pulling from the server and then pushing to you. Actually, my cell phone doesn't even right now pull the messages until I go to the mail program. So right now if I go and say mail, then only it will start pulling. Otherwise, for 7 days, it hasn't done a thing. Yeah, I can configure differently. Then there will be, so for example, in my laptop, I have configured that every 1 hour it should go and pull. Right? I can program that it should go every 5 minutes and pull. Or it should program every 1 day and pull. So say your configuration thing, but not the protocol thing. You have to distinguish between the protocol and your configuration. How often do you pull? That looks like a push, but it's not a push, it's a pull. So you can program your mail program to pull every second. Alright, so I'm not going to go into detail of IMAP because really all I wanted to do was to give you an idea of the differences of these different applications, how they worked and as compared to HTTP and so on and so forth. So we have done that. And so we finished FTP and mail. FTP is a client server protocol and it uses the port 21. It uses 2 parallel connection. So again, when you use 2 parallel connections, that means you use 2 different port numbers. Port number 21 is for the control connection. And SMTP is the protocol to send email, and it only does 7-bit ASCII. So there is a whole detail how do you convert messages to 7-bit. And then there are other protocols that can be used to receive the email. What port number? Yeah, that can be negotiated. So basically, what happens is there are 2 sides, 2 port numbers. So when I am talking, let's go back to a simple case, HTTP. HTTP, the server has a port number 80. But when the messages come back to my computer, they also need a port number to get in. Right? That port number is totally arbitrary. I could send to the server, say that please, I want this page and my port number is 3021. Right? When the server responds, because server is getting unannounced call, right? So it has to go to port number 80, right? Because we have to know who to give it, right? But I'm not getting an unannounced call. When the answer comes back, it goes to port number 3021 because I said so. So this one side of the port is random, right? Similarly, in the FTP case, when you want to just tell the FTP server that I want to talk to you, you talk to port 21, right? And then you say, well, my control port number is 3023, and then connection is set up. We say user, password, and so on and so forth. Then I say, okay, I want. Then it might say, okay, for my data, please use this port number or whatever it is. So the rest of the things are all arbitrary. You need just the first time when you go unannounced, you need a standard port number. Yeah.
Is the port message provided by the socket?
Okay, the question is who provides the port mechanism. So basically, if you go back to the, I am looking for a 7-layer model somewhere. I don't know whether it is in this slide set. Yeah, here it is. You see, at any point, we need an address to go to the next layer. So when we come from the Ethernet, and there are dozen computers on this Ethernet, it has to know which computer to give this message to. So there is a Ethernet address that gives it to one of the computers in the IP layer, right? And actually there is a corresponding IP address. Then the IP, whatever gets it, so my computer got this message, now it has to decide which of these applications to give. So TCP, when it gives it to any, then it uses the port number. So port number is simply a TCP address. So TCP has one address for HTTP, one address for FTP, one address for SMTP and P2P and so on and so forth. So port number is nothing to do with the socket whatsoever. Port number is the TCP layer address. As the IP layer address is that 4-digit number, there is the Ethernet level address, which we haven't talked about. So each layer has its own address. And actually applications have their own address too. For example, when you go to HTTP server, you give it a URL. URL is the address. The question is, suppose I have a new application, how do I get the port number? You have to go to IETF and you have to say, I want a standardized port number for my application. You have to make your case, and if they think that your case is important, strong enough, then they will give you a assigned number, and there is an RFC which has all these assigned numbers. Hold on. So once you get that, then everybody in the world will follow that. If you're not in that list, you're not a standard. So yes, there is a person who does assign. Actually, it used to be a person who used to do this in the old days. Now it's a committee. Okay, socket concept is basically an operating system concept. Nothing to do with the networking. In the original Unix, when process A wants to talk to process B, they opened a socket, which is now looks like similar to port number. But even if you are not going over the network, suppose you want to talk to another process on the same system, you will open a socket. Okay? Now, in the case of networks, what happens is each of the applications is talking to the TCP process, TCP IP process. It's a separate process. So they have a socket opened. And when port 80 comes in, it knows that port 80 has to go to that process. Okay? So socket is an operating system concept, port is a networking concept, and port is related to TCP and UDP. Okay? If you had another transport protocol which we don't have today, then they would have a different address mechanism, different address sizes, different whatever. But TCP and UDP use 16-bit port numbers. So the port numbers are between 0 and 2 raised to 15, 2 raised to 16 minus 1.